Let's start section 4.5. We want to solve exponential and logarithmic equations. We've already solved some equations like these earlier in chapter 4, but now they're going to get just a little more difficult. So here in this first example, we're given the equation 3 raised to the x power equals 7. We solved a similar equation in section 4.2, and the way we did it was we got the bases to be the same, and then we set the exponents equal to each other. Well, we're not going to be able to do that now. 3 and 7 can't be written with the same base, and so we need a different technique. So what we're going to do is we're going to take the common log of both sides of the equation. And then we know there's a property of logs which says we can take the exponent out in front of the logarithm. So we can rewrite the left-hand side as x times the log of 3 is equal to the log of 7. And log of 3 is just a number. It's being multiplied by x. So we can divide off that same number and they'll cancel. We have to divide by log of 3 on both sides, and we're left with x is equal to log of 7 divided by log of 3. And that gives us an exact answer, and then we can put it in the calculator and get a decimal approximation. So I've already typed it in. It's log of 7 divided by log of 3. If we round to 3 decimal places, we get 1.771. So let's write in our answer, 1.771. I want to emphasize that we're finding the answer two different ways. We're finding an exact answer, which in this case requires logarithms to write it, and then we're getting an approximation as well. I also want to remind you that instead of using common logs in this to solve this equation, we could have used natural logs, and it would have worked the same way. We would have taken the natural log of both sides in the first step, and at the end we would have wound up with the natural log of 7 divided by the natural log of 3, and that would be fine too. There's one more way which is not as good. You could take the base 3 exponential here in the problem, and you could rewrite it as a base 3, as a log with base 3. And that would be okay. You could use the change of base formula to finish the problem, but that method won't work in some more complicated equations that we're going to solve later in this section. So really the best way to solve this equation is to take the common log of both sides, or if you prefer, the natural log. Okay, let's go on and see another example. So in example 2, we have 0.05 multiplied by 1.15 raised to the x power is equal to 5. If you have an idea how to solve this problem already, then pause the video and give it a try. The problem is similar to example 1, except for the 0.05 out in front. What we want to do in the first step is we want to divide off the 0.05 so that on the left-hand side we're isolating the exponential. 0.05's cancel, and we're just left with 1.15 raised to the x. 5 divided by 0.05 is 100, and so that's convenient. And now the equation is equivalent to the one that we solved in example 1. So we're going to take the same steps. We're going to take the common log of both sides and then use the property to bring the variable down in front. So let's go ahead and do that. Let's take the common log on both sides. Let's bring the exponent down in front. X times the log of 1.15 is equal to, oh, I was going to write log of 100, but you know what that is, right? Log of 100 is just 2. 10 to the second power makes 100. So then we can simplify that, and then we can divide off the log of 1.15 on both sides. And we've got x is equal to 2 divided by the log of 1.15. And let's put that in the calculator here. So 2 divided by the log 1.15. And here's our answer, 32.950. Remember, if we're going to round to 3 decimal places, we have to include the 0 in order to show that we rounded to 3 decimal places. If we only wrote 32.95, that would imply that we rounded to 2 decimal places. So 32.950 is our answer. 32.950. And again, we wrote an exact answer and then a decimal approximation afterward. Okay, that'll get us started. We'll go on and solve a couple more exponential equations in the next video.